Okay, so today we're going to continue on SQL, probably all the way into Thursday, definitely into Thursday with database design. Keep in mind that next week is our midterm. That's on Thursday. I have made it up. It is 25 multiple choice questions. It'll be traditional Scantron right here in the same room at the same time. So make sure that you bring a number 2 pencil. The reason I haven't switched over to the testing center is because they do allow open book, open note, open computer tests, but no, not open book, not open computer. You're only allowed to have at most 1 sheet of notes. So my exams are open book, open note, open computer. So we'll go ahead and continue to do Scantron until they start to accommodate that kind of an exam. It'll cover everything that we've covered up to and including SQL. It will not cover JDBC, which we will cover probably after next week. But hopefully we'll get done with SQL and databases this week. If not, then that'll bleed into Tuesday of next week, and then we'll also have a bit of a review. The review will simply just be me bringing the big giant question repository that has, I think, 400 or 500 questions. We'll do as many as you want, and those questions, the questions for the actual exam, are randomly chosen from that set. So that'll be the form of the review, depending on how much time we have next Tuesday, a week from today. Okay. So to continue with SQL and databases. Remember that the whole reason that you want a relational database management system, well, a lot of reasons, but one of the reasons is that you want to normalize your data. You want to separate the data out into separate tables so that you reduce redundancies. Remember over here in our game example, we've got a game table, a platform table, a publisher table, and then a join table in between them to join those two things together. And that's what we're actually going to look at starting today, joining these different pieces of data in different tables back together again so that we can actually query. For example, last time we queried all the publishers, we queried all the games, and we got an independent list. What I want to do is I want to take those two things and I want to join them together so that I get a list of all the games along with their publishers. Now, that's where you're going to get redundancies again, right? When you take it back to that flat file that you were working with on your very first homework. You had several instances of publishers that were repeated, right? And that's okay when you query it out for the result. But as far as storage goes, we want to eliminate those redundancies. So we're going to be querying it out, but we're going to be recombining them together. The way that we do that is we take table A and table B, and we join them together. So we do this by joining, and it is a keyword, joining together one or more tables, right? And the way that we do this is, well, with the keyword join, right? You can join two tables together on, and that's another keyword, on a particular value. Right? And the particular value that we're going to use is a foreign key. Remember over here, let's just go ahead and look at the game and the publisher tables together here. The publisher and the game has a game ID, a name, and a publisher ID. The publisher ID is a foreign key referencing back to its parent, right? The parent here being the publisher. The publisher has a publisher ID and a name. Well, the design was explicit about that the publisher ID over here in this table and the publisher ID over here in this table, those two things match to bring records together in those two tables. That's what we're going to be joining on. All right. Just to give you an idea here, I'm going to give you a picture of this. Right? And this is not going to be games. It's going to be something else. All right, here we go. Not big enough. There we go. There we go. All right. So these are different tables. I've got a student table and I've got an email table. It's the exact same kind of relationship. A student can have multiple emails. For example, if you look, Ryan Sandberg there has 2 emails, right? You could also have 1 email, or no emails, or 5 emails, or 10 emails. So I've got 2 different tables here. What do you think the relationship is between the two? There's a one-to-many relationship from the student table over to the email table, right? I want to join them together. How do I join them together? What's the common column there? The student ID, right? In the student table, that's the primary key that identifies a student. And in the email table, that's a foreign key that refers back to that primary key. Right? So when I join them together, I get something that looks like the table and the third table there in the bottom. That Sterling Castro there has a student ID of 1234, and he matches with this. If you look in the second column in the second table, that last record, right? Number 13 at Cubs.com. That's how you got the result there on that in that third table on the first row. Let's see, who else is there? Anthony Rizzo is 5678, and he matches the third record in the second table. So that's how we get that second record. And then finally, Ryan Sandberg, the last one, Ryan Sandberg is 9988, and that matches the first two records. So consequently, we have two records in the third table there. However, we do have one student record here, Dale Sweem, that does not have an email record. So consequently, does he show up in the join table? No, right? We'll talk about that shortly here. But that's the idea. The first record matches the fourth record over there, and so that's how you get the first record. The second record matches the third, and the last record there matches the other two. And of course, Dale Sweem here is unmatched, so we don't have a record for him anymore. Okay? How do we actually do this as far as syntax goes? Well, first of all, I'm set up here to use the same database. Again, we've got publisher and game. Let's only concern ourselves with those for now. What I want to do is I want to look at all the games, and then I want to get their publishers. Okay? So I start at the game table. Right? I'm doing a join of this table, of this game table, over to the publisher table so that I can get all their publisher IDs. Right? So I'm going to go ahead and just select everything for now from the game table, game as G, join the publisher P as P on, and then remember the as keyword. What does the as keyword do from last time? It aliases it. And the reason that I want to do that in this instance is so that I don't have to rewrite the table names every single time. I'm going to join them on, what was the common column here? Publisher ID, right? So I'm going to join them on game's publisher ID. Publisher ID is equal to the publisher.publisher ID. Right? So before I continue here, we see some syntax that's kind of familiar. If I'm talking about a table and a particular column in that table, what did I use to get that particular column? The dot. It's a dot operator, right? Very, very C-like, right? In fact, SQL predates C somewhat, so it's maybe it's actually from SQL, right? I don't know the particular history of that dot operator, but there it is, right? Let me go ahead and do that, and let's see what we get. So there's GTA 4, 3, 2, 1, et cetera, and we've joined it now to the publisher ID. Publisher ID, publisher ID, those are always going to match because my clause here was saying that the game's publisher ID has to equal the publisher's publisher ID. Right? And again, without these, let me go ahead and close this for a second. Without these aliases, what I would have had to do is go game dot and then publisher dot, and I would have had to use the full table name rather than using those aliases. But I don't like to do that because I like to shorten my SQL queries up. And so one thing that you can do is you can omit the as keyword. Right? You can now go ahead and say games G or game G and publisher P instead of using as, and now it's even shorter. Right? And that's about as short as it can get there. Okay? How many records do we have? 20. Do you remember how many games we actually had? Let's see. Select star from game. Or no, you remember how to determine how many records there are? There's an aggregate function called count of everything from game. Right? There we go. And there were 20. So when I run the second query here, I get 20 records. Okay? Again, redundancy is reintroduced in the actual result. Rockstar Games is now here for 4 times, maybe more down here, I'm not sure. Nintendo is there for 3 times. And I've also got 2 copies of the exact same thing, publisher ID. Right? Again, if you don't want to do that, then don't select star. Select only which you want. Name and name, right? I want the game's name and the publisher's name. Uh-oh, what's going to happen there? I want the name. Which name do you want, right? There's a name over here in this table and a name over here in this table. So now here's a situation in which I have to disambiguate this using those aliases. So I want the game's name and I want the publisher's name. P dot. There we go. And when I run that, now I've gotten rid of all the internal keys. The foreign key I don't care about. The primary key of the game I don't care about those. I just want every game listed along with its publisher. Now it's looking more and more like the CSV file that we had before, right? That you had when your first assignment. Okay, that's good. Except, are they in any particular order? Not really. So here's one thing that we can do to impose orderings. You can order a result from a query by using the order by clause. There we go. So let me go ahead and get this again. And so how do you want to order these things? Do you want to order them by the game title? Okay. Order by, right? And now it's highlighted there, so it's actually going to work. Order by g.name. Right? Let's go ahead and run that. And now you see they're in what order? In the first column here. They're in lexicographic order. Right? What if we wanted to do it by publisher first? What would I do instead? Instead of game.name, it'll be publisher or p.name. And now Capcom is first and Valve is last. All right. You can also do a combination. Right? You can say that there are ties, right? Say that there are ties among the publisher. Then so we'll order them by the publisher, but then the games. Then we'll order them by the game. So p.name and then g.name. And if you take a look at this, it's the same order as before on the right, on Capcom down to Valve. But if you look at, say, Rockstar Games here, where you've got 4, then these are now ordered in order, in lexicographic order. Nintendo, Legend of Zelda comes before Zelda. L comes before Z. Right? So you can order things in multiple ways. Right? And it's still a little bit unsatisfying there, because if you look at the top, and again, it's difficult to see because it's small. If you look at the top, this column is still just name, and this column is still name. If I were doing something programmatically, like I was writing a Java program to pull these 2 things out, then I still have an ambiguity. Which name do you mean? Right? Do you want the first name or the last name, and what are they? Again, this is another perfect instance in which you want to use an alias on your results. So as game title and as publisher name. Right? And when I do that, and again, you can't see it, but it has now been disambiguated. I've got 2 unique names for my columns now instead of the same name. And now in my Java program that I'm writing, I can pull out the game title or the publisher name, and there's no ambiguity there whatsoever. Okay? Well, there's still a problem here. Did we get all the publishers? Right. So let me go ahead and select. I'll just select everything from publisher. Right. All right. There's LucasArts, there's Atari, there's Valve, et cetera, et cetera. If we go back over here and look at these, do you see Atari here? Do you see Atari represented? No. Why is that? Let's go back to our ER diagram here, and let's ask the question that we've asked before. Can a game exist without a publisher? No, because if you look at the game table, it requires a game ID, a name, a title, and a publisher ID. In other words, for a child to exist, your parent has to exist first. So if you're going to create these things, you have to create the publisher, and then you can have to create the game. Well, there's nothing to stop me from just creating the parent. Right? A childless parent is they can exist. Well, then they wouldn't be called parents, but that it's not a one-to-one correspondence with real English here. A parent can exist without a child record, right? Like Atari. Atari has no, at least in our database here, has no records of a game being published. So I would really like to include Atari here, even if I want to include all of the publishers, whether or not they had a game or not, right? So it's kind of like this over here where we had these join tables. Dale Sweem did not show up because he didn't have an email table. I still want him to show up because I want to create a roster for my course, listing with all the students, whether or not they have an email or not, right? That gives us what's called a left join, right? It's called a left outer join. Don't worry about that. It's just a left join for us, okay? So you're going to be joining A to B like we did before, but you're going to put a left in front of the join. And when you do that, it leaves all of the records there. Forget about that. The only difference is that when there's no record, so I'm doing a left join, I'm taking this, and then I'm joining it over here. When I do that, then Dale Sweem, who doesn't have a record on this part over here, he's still preserved, okay? And just in case you are wondering, there is a right join. I'm not going to cover it, because all you need, if you're going from A to B with a left join, guess what a right join is? B to A, right? So I like working left to right. I've never used a right join before. You're writing backwards in my mind. You are writing from right to left so that you can do a right join. And that seems so wrong that I just only ever do left joins. Okay? Let's come back over here and let's revise this now. Right? All I'm going to do is copy and paste the same one over here. The only difference is on this join, I'm going to go with a left join instead. And now we'll see Atari as well as all of those other publishers that didn't have a game preserved. Right? Oops. Nope. Ah, okay. Darn it. Thank you. All right, let's start from scratch. So I'm going to, where do I start? I want to start over here on the publisher. And then I want to join it to game, so this is why I'm going to left join. I'm reading left to right. I'm going to start at the publisher so that I include all of the publishers, whether or not they have a game. And then I will do a left join onto the game table. And for any publisher like Atari that doesn't have a record, over here in the game table, it's just going to, the value is going to be null, right? So let me go ahead and start from the, I'll select everything here. From publisher P, left join game G on p.publisher ID is equal to g.publisher ID. And by the way, the order here doesn't matter. You can go P or G. It's an equality. Left join, right join. This doesn't matter because if A is equal to B, then B is equal to A. Right? And is that all I need? Left join. Oh, let's just go with this for now. There we go. And let's see. Where is Atari? There we go. Atari. Do they have any games? No. So the game ID, the name, and the publisher ID are all going to be null values. Capcom with 2 games. Those records are preserved as before. Right? But for Blizzard Entertainment, Atari, Sega, Sony, and Square Enix, so I've got 5 publishers without a game. Remember that because we'll come back to it later. Right? And that's a left join. So it's just it's the difference between a join and a left join. And by the way, there are several other joins. There's a full outer join, which is basically a Cartesian product. There's right joins. There's a few others. But I'm only going to distill it down to 2. The regular old join and a left join, because that's really all you need. If you find yourself needing to do a full outer join like a Cartesian product, rethink what you're doing because that's going to be order n squared. And for a moderately large database, that's not going to be practical at all. Right? If you're taking 235 right now, a lot of this might sound familiar, especially when I said Cartesian product. If you've got a set and another set and you want to bring them together by taking, say, if I've got ABC and 1, 2, 3 over here, then a Cartesian product is for each one over here, I match it to one over here. So I would have A, 1, 2, 3, B, 1, 2, 3, and C, 1, 2, 3. In other words, 3 times 3, 9 records in that Cartesian product. That's exactly what a join is doing, at least a full outer join. A left join or a regular join then pairs that down. Instead of pairing everything up for all pairs, you have a first order piece of logic like the publisher IDs being equal. Right? And when you've got a first order logic like that, then you are pairing it down. You'll eventually get to this. It's called a relation. In mathematics, it's called a relation. Well, why would we call it a relation? Where have we heard that before? Relational database management systems, exactly. 235 is going to give you the underlying mathematics to all of this stuff. Okay. All right. Oops, I didn't want that. There we go. All right. So that is a left join. All right. What else? Joins. Oh, and then going back to what we wanted to do earlier. Where is it? Where's my example here? Oh, here we go. Starting here. So now we can actually do something a little bit more. We can actually start doing data crunching within our database system itself. One thing that you might want to do is a projection. Remember last time I left you off with what happens when you take a cube, a 3-dimensional cube, and you project it down onto a surface like a table. You get a square. A square is a 2-dimensional analog of a cube. What happens when you take that square on two dimensions now, and you go down to 1 dimension? What do you get now? A line. What happens when you go down to 0 dimensions? Now you get a point, but you can't go any further, and a point is not necessarily all that helpful. But what happens when you go up, right? You can go from 4 dimensions down to 3 dimensions very easily, conceptually at least. That's kind of what this is doing. Suppose that I've got a book table here. I've got records of titles, authors, and then a number of copies of each one of those books in my collection or in my library. For example, we have 10 copies of The Naked and the Dead by Norman Mailer, or just 1 copy of The Long Dark Tea Time of the Soul by Douglas Adams. What I want to know is how many books, how many total copies of books do we have by each author? Right? The idea here is that I'm taking a 3-dimensional object, right? Something with 3 columns. And I'm going to project it down onto 2 dimensions, right? The dimensions that I want are the author and the number of books, number of copies of total books that they have in this collection. So the idea is that we have a group by clause. The group by clause is going to take all of those authors and group them so that all the Douglas Adams entries are together, so that all the Norman Mailer entries are together, et cetera, et cetera. And then what we can do is we can project it down. Once they're grouped, I want to take this 4, this 2, and this 1, and I want to sum them up. I want to take this 10 and this 3, and I want to sum those up. This 7, I want to sum that up. It's just 7, right? So that I can, once I've got those sums, I can project it down onto 2 dimensions. Ignoring this 3rd dimension over here, I don't care what the titles are. I just want to know what are the authors and how many books do they have, right? And so I want a result that looks something like this, okay? How would we do something like this in the game database here? For example, I want to know how many, for all the publishers, how many games have they published, okay? So the syntax for doing this is very, very similar to this right here, where we have to actually join things together. So I'll go ahead and select, I'll come back to what I'm actually going to select here in a moment. From publisher P, join game G on p.publisher ID is equal to g.publisher ID. All right, there we go. Now when we do that, I'm going to go ahead and order them by the publisher here. What I want is, I want Capcom, I want 2. Capcom has published 2 games over here, whereas Rockstar Games, they've published 4. So I want to collapse that down. I don't want 1, 2, 3, 4, 5 dimensions. I only want 2 dimensions, the publisher and the number of games that they've published, okay? So let me go ahead and modify this. I want the publisher.name as publisher name, and I want a count of the number of records. So as a first attempt here, let me go ahead and go with count star, okay? From publisher P. Now, I have to specify how I'm going to group them. Let me go ahead and go back over here to this first one. There we go. How do I want to group them? and this is backwards, but I want to group them by their publisher. So one thing I could do is I could group them by their publisher name. Get rid of that. I could go ahead and say group by p.name, right? And let me go ahead and try that. Right? And there's what I get. I grouped all the Capcoms together, or I grouped all the Rockstar games together, and I collapsed them down. I took those 5 dimensions and I projected it down onto only 2 dimensions, giving me a sum of all those things. Right? Now, there's still a problem here. When you do this, my database here was well designed, so I don't have like 2 valve records, right, where there's one valve and then another valve that was accidentally inserted. But it's best not to use something that's non-unique, right? A name does not identify a publisher. Remind me, what identifies a publisher? The publisher ID. It's key. So if you're going to do something like this, you should publisher ID. You should generally use the ID. It's going to, at least in this case, it's going to be the exact same result, but it's a little bit more, it's a little less brittle, I'll say. Because if you do come in here and now there's a duplicate record of the Rockstar games, well, now you're going to have, now Rockstar Games A and Rockstar Games B, they're going to be collapsed down if you did it by name. But if you did it by ID, and these 2 things are distinct, then it'll keep those 2 records as distinct. Okay? All right. Well, that seems good, except for, remember I told you to remember something. There were 5 publishers that what? That didn't have any games. Atari was one of them. Do you see them here? Nope. So what should I have done instead to make sure that that shows up? Oops, sorry. Where is that? There we go. A, left join. Okay. Did it work? There's Atari, right? Yeah, it says it has a game. What am I counting here? Count star. Let me go back over here to the left join, this one. Right. If I'm just counting the number of records, the number of lines, the number of rows, well, of course, how many rows are there for Atari? 1. And that's where I'm getting that 1. Right? Capcom, I'm still getting 2 because there are 2 rows here. That's not what I want. What I want is, I want to count what? The game ID, the number of games. So if I count the game ID and null, what do you think null's value is? 0. So when I count something that has, sum up something that's null, it contributes 0 to that summation. So I shouldn't be counting star, in other words, counting all of the rows that you have in your result. I should be counting what I'm interested in. I want to know how many games that publisher has published, and how do you uniquely identify a game? It's game ID. Right? So I'll count the game IDs. Game ID. There we go. And now when I do this and sort it, now Atari has 0, Blizzard has 0, Sega has 0, Sony and Square Enix also have 0. Those are my 5 publishers without any games. Right? Great. Now now we're at what we want. So that's the syntax for that. You can further limit the results of a join/group using another keyword. And I'll come back and tell you what that is. But here's my goal. What I want is select only publisher records that have no games published. Right? So for example, I don't want this. I just want those 5 publishers that have 0 games. Okay? Well, you might be tempted at first to say, okay, where? Oh, and by the way, what did I call this? I should put this as an alias as number of games. There we go. So that I can use it over here, where number of games is equal to 0. Okay? Let me go ahead and try that. Well, first of all, it's not letting me even do that. All right? Yeah. And because of this red X over here, what is it complaining about? Didn't I already have a where? Or no, I don't have a where here. but I have an on. The problem here is that you've got lots of things going on. The way that I'm doing this query is I've got this publisher table and this game table, and I'm joining them together. When I join them together, I join them on something, right? And then I group them so that I can collapse them down, so I'm creating basically a new table over here, at least temporary, right? If you wanted to limit your results using the where clause, that had to happen before the group by. So you join them together, right, on something, and then if you wanted to limit it further, you could put a where clause in there, like where the title starts with a G, right, like we did last time. And then you could group them all together and get your result. For example, let me go ahead and not do this one, but let's do this. As number of games from publisher P, join blah, 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 where game.name like, what was my wildcard? Remind me. How do I want it to start with a capital G and then match anything else. What was my wildcard? %. Oops. Okay, because I've still got this over here. Forget about that for a second. There we go. And run this. And there. Now I'm only getting Rockstar games, those 4 GTAs, right? Grand Theft Autos, 1, 2, 3, and 4, right? So you can use a where clause, but it happens before you do a grouping, or before you do that collapse. So to actually get this to work, I can't use where. Instead, I need to use another keyword called having, right? Having. There we go. So once I do this having number of games exists after the collapse, right? And so I'm saying where it is equal to 0. Having number of games equals 0. When I do that, now I get those 5 publishers right there, all with 0. And of course, it doesn't have to be equal to 0. It could have been, well, okay, I don't care about those other publishers. I just want to know if they have more than 0. Or more than, say, I don't know, greater than or equal to 4. Having greater than or equal to 4. And I get those 2 results instead. Okay? So lots of things that you can do here in the database itself. And you'll discover that tomorrow when you start working with the albums database. But the having has to come after any group by clause. If you want to limit the results before that, that's perfectly fine. You can use the regular old where clause. Okay. Other aggregates. Right? So here's my goal. One of my goals is find the oldest game in the database. Okay. Let's come over here to the video game database. And how would I go about finding the oldest game? I would need to find the oldest publish year, right? Well, publish years are numbers. So if you want to find the oldest one, what would it be? The smallest number, the minimum, right? So let me go ahead and start by using an aggregate function. Select everything from availability, right? I'll just show you everything here. Well, I could just go ahead and sort this and go, okay, the oldest game is from 1985. Does that tell me what the game is? No. And I had to select everything just to get the minimum. Well, you can go ahead and select the min of the publish year, from availability, and you'll only get 1985, rather than transmitting all of that data across the network. Right? I want the oldest game. I don't know what it is, but now at least I know that it was published in 1985. Okay. So now I need to go back to the game table and find that, which was what was it before? Select everything from availability. Okay. Now I go ahead and run this again. Well, 1985. That's game ID 6, published on platform ID 6. So now I'll go ahead and select everything from game, and what is game number 6? Oh, Super Mario Brothers. All right, there's my answer. That's multiple queries. It's looking at it. I was doing manual labor to find that, right? I don't want to do manual labor. I just want to write one query that will tell me exactly what is the oldest game in the database, including the name, the publisher, and maybe what platforms it's available on. Okay? To start that out, I'm going to want to take the entire database and collapse it down into one, join everything together so that I go back to the square one, homework number 1, where you've got a flat file, a CSV file. Okay? Let me go ahead and start by doing that. Let's go down. Select, for now I'll just select everything. From, where should I start in all this stuff? If I want to take all 4 of these tables and shove them together. If I start at the game table and go over to the publisher table, you could have an argument there because what I want to do is I want to find the oldest game. Well, if a publisher doesn't have any game records, then by definition it doesn't have the oldest game. So you could start at the game, go to the publisher, then go to the platform or whatever. I'm going to go ahead and go in order here, though. Publisher over to the game. Right? With respect to the game, I want to get over to its platform. What do I need to do? How am I going to have to join those 2 tables together? I'm going to have to go to that intermediary table. Right? That's why, again, we call them. This is called A. The availability table is called a join table. It joins those 2 things together. So I'm going to start at the publisher, go to the game, go to the availability, then go to the platform table. So it's going to be a really large query here. That's perfectly fine. Select everything from publisher, P, join. White space doesn't matter, so I'm going to go ahead and go down to the next line here. Join game, G, on. P.publisher ID is equal to G.publisher ID. Join availability A on. How do I join from the game table to the availability table? The game ID, right? Again, now in this sense, the availability table is a child and the game table is the parent. So I've got a foreign key referencing back to its parent's primary key, which is the game ID. On G.game ID is equal to A.game ID. And now, oops, I don't want these. There we go. Join. Now, how do I go from the availability table over to the platform table? To with the platform ID. So join platform P on A.platform ID is equal to P.platform. Right. So this is not going to run. Let me go ahead and run it. Right. And it doesn't run. Why? I've got 2 aliases with the same name. Publisher P and platform P. You can't use these same names. Just like you can't have the same table, 2 tables with the same name in the same database or the same schema. So I'm going to have to call this something else. What should I call it? Platform, or I don't have to alias it at all. I could just say platform ID. There we go. And run that. And now I get all the data in the entire database. Except, do I get all the data in the entire database? There's the publishers. What do you see missing again? The ones that don't have games, right? So if you want to, you can change all these to left joins. Then left joins. Except for this last one. Do I need a left join on this one? Availability over to the platform table. What would you be getting? The availability record may or may not exist, right? If a game was not published on any platform, I'll still be getting that record, right? If I go from the availability, if it has an availability record, though, if this Super Mario Brothers was published in 1985, then it necessarily has a platform record. Why? Because it's its foreign key, right? Can remember over here, game. Can a game exist without a publisher? No, because a child cannot exist without its parent. So can an availability record exist without a game? No, because again, it's a child. Likewise, can an availability record exist without its other parent, the platform? No. That's what brings those 2 things together. I might have platforms that have no games published on them. That's a different query. I would have to start at the platform table and then go down to the availability table to determine whether or not I have such records. But for this one, I don't need to do a left join. I just can do a regular join. And when I do that, now I get, where's Atari? Oops. Nope. Looks like let's go ahead and go with that because I lost the record. It doesn't matter because I don't need that record. But there's the Atari record. You see that it was null all the way over to the rest of the database. Again, I'm not interested in that because what I'm actually interested in is the oldest game here, right? And where is it? Uh-oh. We lost it somehow. Oh, there it is, right? Why didn't it go to the top? Weird. Okay. Huh. That's my SQL workbench. I don't know why. Okay. What I want is I want to find the oldest record. So where a dot publish year is equal to 1985. And when I do that, I'm only going to get that one record, Super Mario Brothers, published on the Nintendo Entertainment System. Okay, that's min. What about the oldest? That would be 2011, or sorry, the oldest. That is the old. The other one was the oldest. This is the newest. So 2011, I'll actually get several records. Porthole 2 was actually available on multiple platforms. Okay. Question was over there? No? No? Okay. All right. But that's still kind of fragile. What if I inserted a new record, say Pong, 1970 or whenever it was done? If I hard code this to 1985, am I going to always get the oldest record? No. So what can I do? I can take this query and use it as a subquery. And instead of max, I'll go ahead and go with min. Right? And when I do this, it's exactly the same thing, but now it's future-proof. Right? If I insert a game that's older, 1970, then this query right here will still work going forward. Right? And again, you can go ahead and not select everything because you don't need a repetition of all of these IDs. You may not even care about the IDs. All that you care about is the name of the game, the name of the publisher, and the name of the system that it was published on. Okay. All right. Those are group bys. Okay. There we go. Here's another. And ignore that. Here's another useful. I don't know. Useful kind of aggregate. It's not really an aggregate, but it is useful. So select everything from, or no, what I want is where let's see. There we go. Nope, that's not what I want. Uh-oh. Undo. You're kidding me. I lost everything. All right. Undo, undo, undo. Nope. All right, I never saved it either. Don't worry. I'll do this all again, and then I'll still have it in the notes. Unfortunately, so now we have to start over. What did I want? Oh, I wanted uniqueness. Okay, so let's go ahead and select all games with their publishers. Right. So, or select all publishers that have games. Right. There we go. So select everything from game G join publisher P on G dot game publisher ID is equal to P dot publisher ID. There we go. So there, I've got everything there. What I'm interested in, though, is the publishers that actually have a game. So I don't want these repeated. I'm only interested in the publisher name, p.name. Right? And when I do this, I get multiple records. If I want to collapse those down without using that having a group by clause, what I can do is I can select distinct. There we go. Not unique, distinct. Right? There we go. And now I'm only getting distinct records from that query. All I did was slap a distinct on the front of this name right here. And when I do that, then it takes out duplicates for me. And you can use that in conjunction with order by name. Right? And now they're in alphabetical order. By the way, you can also go in reverse order. So what would be reverse order be? What do you think? So this is an ascending order. So the opposite of ascending is desk, or short for descending. And now it'll order it in the opposite way. Okay. All right. Questions so far on any of this? Otherwise, I think that is all of the basics of joins, aggregates, group by. You can do other fancy stuff if you really wanted to. For example, you can select publish year from availability. There we go. I get all the publishing years. Not only can I get the minimum and maximum of this, but I can get the, what else might you be interested in? How old is the average game that we've got in this database? AVG would be average. And here I'm getting into a bad habit. It should be AVG, all lowercase. There we go. So 2000 it looks like. That's just all the years added together, and then it's taking an average of all that. What else can you do? You can go ahead and take a sum of all the years. That's not really telling you anything, but 52,000 it looks like. Then you can do your own mathematics. You can go ahead and go multiply by 100. So that's not 52,000 anymore, it's 5.2 million. Right? You can do basic math if you really want to. You could go ahead and do the average yourself, right? Count star from select count star from availability. There we go. So if I divide by these, then I'll get that 2,000 again instead of the average. But you can do that directly using the average. There's a lot of other stuff that you can do. There's a lot of stuff that's built into these things. Their concatenation or date time kind of stuff. It's basically a full language, right? The Java standard library is thousands, millions of lines of code and millions of different functions that you can call. Likewise, SQL has many, many functions that you can call. I'm only covering a small subset of it because, unfortunately, there are lots of SQL variants. For example, where's my notes? Let's go back to the notes here. Let's go back to the very beginning, something I don't usually cover, but it's covered in the videos. There we go. Relational database management systems. Here are some examples. All right. Some examples include MS Access, which would be in the Office suite. It's not a real full database, but it basically it can do the job for you if you really want. MySQL, which is owned by Oracle. MariaDB, which is a MySQL clone. PostgreSQL, or just Postgres. Informix and DB2, they're IBM products. SQL Server, or SQL Server, that's a Microsoft product. Then the full Oracle database, SQLite, is for embedded systems, etc. The problem here is, well, first of all, lots of these things are paid products. For example, MySQL, it's free, but we say it's free as in beer, if you've ever heard that term. Free beer is beer that you don't have to pay for, but once it's drunk, it's gone, right? Free as in freedom is what we mean when we say free and open source software. Look at Postgres. Postgres is true free and open source software because you can download the source code, you can modify it, you can sell it, you can do whatever you want with it within that licensing agreement. You can't do that with MySQL. MySQL is not open source, and even if it were, Oracle could come in tomorrow and say, no longer free, now you're paying us $100 a month or something for it, right? Like the other ones. SQL Server, probably $500 to $1,000 maybe per year. I'm not sure. I've never actually paid for it. Oracle, you're talking about millions of dollars. Likewise, Informix and DB2, they're going to sell you whole packages, not just their database systems, but all the hardware that goes with it, right? So there are a bunch of commercial systems. The problem with it is that they have to compete with each other. So each one of them has their own dialects. For example, Oracle has PL/SQL. For Microsoft, or for SQL Server, it's going to be Transact, I think they call it, Transact SQL. Basically, they add their own features. And Informix and DB2, they also add their own features. They're not standard SQL. They're only particular to that one database. The problem if you start to use those features is vendor lock. right? If you write 1,000,000 lines of code for Oracle's database in PL/SQL and you're using all their fancy features, guess how hard it is going to be to switch over to SQL Server because they're offering you a better deal now. It's going to be virtually impossible. You're locked into that vendor. You're going to be paying Oracle for the rest of your life unless you want to rewrite everything from scratch. So my advice to you is to stick with the core. Stick with the very basics of SQL and don't use any vendor-specific stuff. Even MySQL, we're actually not using MySQL. I've been showing you. It's called MySQL Workbench, but it's actually not connecting to a MySQL database. It's connecting to a MariaDB database. MySQL was developed by a guy, I forget his name now, that then ultimately sold his product to Oracle. That's when they made it closed source. They still give it away for free for now, at least for now. Again, they could come back tomorrow and say, okay, now we're charging for it because it's free as in free beer. But he didn't like the way that they were going, so he rewrote it from scratch. And he named it after his daughter, and it's called MariaDB. That is true, free, and open source software. It is intended as an open source replacement for MySQL. In fact, the intention is so much there that all of the bugs that are still in MySQL are still in MariaDB 20 years later. Because if you go and fix bugs, you're no longer compatible with this other product over here. So all the bugs are still there, and it really hasn't developed. It hasn't added features in the last 10, 15 years. That's why Postgres is if you're ever going to install and use a brand new database from scratch, I would highly recommend that you use Postgres. It's free open source software. It is cutting edge. It's got a lot of brand new features that say MySQL and MariaDB don't have because of the stunted development there. If you're also interested, there's also NoSQL, which are non-relational databases. For example, key value pairs like MongoDB, Cassandra, Spanner. Spanner, I think, is a Google product. No, it's an Apache product. I forget. Or there are graph-based databases where you can create a graph in memory, like a full-on data structure, and then persist it to a database. Redis is like that, except it has support for a lot of things. It has support for hash tables, so key value pairs, for other data structures like graphs and stuff like that. Or you can choose to go completely on the cloud and use Amazon Web Services, AWS. They use Dynamo and a bunch of other things. They also offer basic straight-up SQL or relational database instance. But for this class, of course, you can't beat free. We're going to stay on the CSE server. We're going to stay with MariaDB, and we're going to stay with that small subset of SQL so that we don't have to go off and get locked into a particular vendor. Okay. All right. Any questions so far? No. No? Okay. Well then, let me go ahead and cut and paste this. And we'll start over here. In the last few minutes here, SQL, there we go. And again, I'll go ahead. I was only able to get this last part here. I'll go ahead and in the second class, I'll make sure that I copy paste it and save it. Otherwise, a lot of that material is available on Canvas already. Right? So my goal here is going to be to create a new database. So my goal is, let's go ahead and create a database to model films, including directors and actors. Okay. Oops. So it's kind of like how we designed objects. We thought about I forget what it is now, a bank account. We thought about what is a bank account. Well, a bank account has a balance and maybe an APR. Oh, and an owner. Well, an owner is a person. So I've got first name, last name. Oh, wait a second. That sounds so useful. Let's separate that out over here into its own object. And a person has an address or a city, state, zip. Well, that's 5 things that it's not a person, so we need to separate these out. That same basic idea of separating things out into their respective tables so that they are representing what they are we're going to follow that with our relational database management system here. So if I want to model films, and let's just say directors for now, we'll go ahead and create those two tables. How would I go about doing that? How many tables are we going to need here? 3? Okay. Well, let's start with just 2: the films and the directors. So let's go ahead and create a table to model films, and then we'll create a table to model directors. Right? And then on Thursday we'll go ahead and finish out with the other ones. All right. So how do you think you can create a table? Create table, right? And what should I call this table for films? Here's my first motion pictures. Something weird like that. Films. There we go. All right. There are several naming conventions that you can follow. As long as you're being consistent about it, we don't really care. But one bad habit that you might get into is pluralizing things. Films, okay, you just add S. But think about English. Do you always add S? No, sometimes you add what? Change the Y to I and add ES. Sometimes you add ES. Sometimes it's completely different words, right? What about focus? What's the plural of focus? Foci, right? Axis. Axes. And sometimes there are multiple acceptable alternatives. For example, if I was doing a person table, what's the plural of person? People or persons. They're both acceptable. So don't get into that habit, right? Besides, it's a table. It's not a films table. It is a film table. The records in it, those are plural. It has film records, right? It's not a films table. And another convention that I generally follow is to use upper camel casing with the table names. If you want to use lower underscore casing, film, foo, bar, right? That's another convention, but I generally try to follow the upper camel casing modern convention here, right? As long as you're being consistent, that's up to you, okay? Or the lowercase camel casing, right? Foo, bar. If you want to do it like that, go ahead. But again, the most modern way, I think, at least in my opinion, is going to be upper camel casing for all of your table names. Tell me what a film is. How do you represent a film? Title, okay. And what is a title? It's a string, right? Dune, or I can't even remember the last movie I saw. I've got Annihilation in my backpack. I'll watch it soon. But those are clearly, strings. So how do I do that? Well, in SQL, a string is a varchar, which is a variable character. I'm just going to go ahead and go with 255 characters here. That's an upper limit, right? If it's only Dune, where there are four letters there, it's not going to take up and waste 251 characters. It's just going to be, okay, well, it fits, and so we'll store it like that. If you have a title that's more than 255 characters, it'll end up being truncated and only store the first 255. There is no null terminating character here. It's not like C. Yeah? You can get big. I think that there's like long text or big text or something like that. Those are just aliases for very large numbers. Very large being like megabytes of numbers. But you're still always, it's a finite thing. I believe MySQL is actually limited to 4 gigs for any one field. So you get above that, then no, it's not possible at all. Yeah. Well, if you are storing blobs I think have an upper limit of 4 gigs. So if you've got a large video, like a lecture video from today, it's probably going to be more than 4 gigs. You would not want to store, you'd want to look for another solution, not store that directly in a database maybe. Right? But I've got a title. What else defines a film? Okay, I could have runtime. How do I want to represent a runtime? kind of like a duration, right? 1 hour and 57 minutes, right? There's no built-in type like that. So what if I made it a varchar, 255, and I did something like this, like 1 hour and 57 minutes. It looks something like that. That's going to be difficult to parse or do anything. I'm definitely not going to be able to do anything with that as far as SQL is concerned. What's another way of saying 1 hour and 57 minutes, though? The number of minutes. So that would be 117, right? So instead of a number, maybe we want to go with an integer or an int. Right? Okay. What else? What uniquely identifies a film? Does anybody know that? I had to look this up. I'll show you. It's an EIDR, right? If you search for Dune, for example, right? There's its EIDR, right? It's an alphanumeric code that uniquely identifies that particular film. Give me your favorite movie. Schindler's List. Okay, I misspelled it. How do you spell Schindler? Schindler's List. Okay, I don't know how to. Give me something I can spell. Hitchhiker's Guide. Okay, it's not finding that out either. All right, I'll have to do some fuzzy lookup or something. But that's an EIDR, right? That's a varchar. It's not going to be 255, so I can go and say 100 or something like that. And it'll look something like this. It's going to be a string with non-numeric characters in there. Okay. That uniquely identifies a film, but do I assign that in my database? Did I generate that code? No. So what happens if there's a data entry error? And I use this to identify this record. Or in another more familiar setting, what happens, do you think an NUID uniquely identifies you as a student here at UNL or an employee or whatever, right? Do you think that they've never gotten an NUID wrong, right? That they accidentally generated two different NUIDs for the same physical person? Or that one person, that two NUIDs were generated for, the same NUID was generated for two different people? It happens. Hopefully it's not that common, but it does happen. An NUID is kind of an external, what's the name for it? It's an external key. It's a surrogate key. That's what they call it. It's something that's generated not by us, but by whoever controls this website, the Entertainment Identifier Registry, right? They're the ones that generate that. It's their responsibility to make sure that all of those things are unique. If they screw up, or if we screw up in our data entry, then that's going to blow away all of our data integrity, right? We'll have to come, if we use this as an identifier in our database, and we've have a foreign key to 5 other tables with this thing, and we find out, oh, I entered that wrong. It should actually be, what was it? Not this thing. I accidentally entered it as you instead, right? Now that error has permeated throughout our entire database, right? So we don't want to use external identifiers as an identifier for our table. Instead, we're going to, but we still might want it, IEDR, right? IEDR? EIDR. Oh, okay, there we go. All right. Instead, we need a different way to uniquely identify our stuff. So primary keys and foreign keys, we're going to let our database handle that stuff. Right? In other words, we want, what were these called again? Game ID, publisher ID, platform ID, availability ID. They were all called, oh, not that, but what does the little picture tell you it is? It's a key, and in particular, it's a primary key. So I'm going to go ahead and have the database itself generate primary keys. So film ID, integer, primary key, not null, auto, increment. There we go. Now let me explain each one of these things in turn. Film ID, I made a very conscious decision to name the primary key after the name of my table. I took the name of the table, all lower camel casing, and slapped ID at the end of that. Why? If you have that kind of convention, Do you need to remember what was the primary key of the game table? Oh, that's right. I followed a consistent naming convention, and it's game ID. What's the primary key of the availability table? Availability ID, right? You follow that pattern throughout your entire database, there's no guesswork anymore, okay? So film ID, now second one is going to be, it's going to be an integer. For another reason, you want to avoid varchars, that is strings, as your keys, as your primary keys at least, because instead of doing a simple integer comparison on your joins, you're now doing a string comparison. And I forget how long it was, but you're looking at strings that are 10, 15, 20 characters long. That's going to be way less efficient than if you just have a simple 4-byte integer. 4-byte integers and integer equality testing, greater than, etc. That's going to be a hell of a lot more efficient than doing character comparisons. Not only that, but character comparisons can be gotten wrong. If your default character set is case insensitive, hello, all uppercase, would match hello, all lowercase, and you don't necessarily want that. So don't face those issues at all. Make all of your primary keys integers. The way that you say that it's a primary key is using primary key, right? There is a space there. Not null means that we're not allowing it to be null. If I allowed a primary key to be null, remember they're unique, how many values could have the key null? Just one, right? Because they're all unique. Not very useful, right? So we're going to make it not null. Auto increment tells the database, generate those things for me, just like the game database does over here, okay? The game database will do, if you insert a new publisher, you only have to provide the name. You don't have to provide a publisher ID. It will be provided for you by the database. The database is very good at handling these things. Let it do its job, okay? All right, so I've got primary key, title, runtime, and this EIDR. That's pretty good for now. So let me go ahead and make it syntactically correct by getting rid of the trailing comma there. And I can go ahead and create this if I really want to, except for it already exists in my database. Let me go ahead and list all my tables, show tables, because I already did this exercise. Oh, tables, there we go. Right, show tables, it was already there. Okay, well, I want to recreate it because I didn't create it exactly the same. So if I want to get rid of a table, create table creates a table, drop table, film, there we go. We'll drop the table. And somebody posted the little Bobby tables, right? Drop table students or something like that, right? And so when that was okay, I can drop that table. By the way, if I try to drop it again, what's going to happen? It doesn't exist, so there's an error down at the bottom here. Let me go ahead and create that though, and now it's perfectly fine. Show the tables. There's film table, describe, film, and it'll show me exactly what I created there. Film ID, title, runtime, EIDR, integer 11, that's just a 32-bit integer. Varchar 255, varchar 100. Right? Are they allowed to be null? Well, the first one, no. The other two, the default is to allow them to be null. Right? This is the primary key, and this is auto increment. So maybe I need to rethink this immediately. Should EIDR be allowed to be null? Maybe if I don't have it, right? But maybe I don't want it to be null, so not null, right? And now if I try to recreate this table, okay, it's not. I have to go up here and do this again, drop the table, create the table, and describe the table, and now, no, it's not allowed to be null anymore, right? I don't like that clicking, right? If I make a change to this table, I'm making what's called a DDL here, a data description or DDL file, data description language file. I'm going to, once I've designed my database, by writing all that, my SQL out here, I'm just going to run it all once, and it's going to create everything for me, including inserting any test data that I want. I don't want to have to go ahead, okay, well, I need to recreate it, so I need to go up here and drop it again, then recreate it, make a change, okay, drop it again, make a change, right? What I want to do is I want one statement that's going to work no matter what. So I'm going to put a condition in here. Drop table if exists. And now I can run the entire thing all in one shot, and whether it exists or not, or doesn't exist or doesn't exist, this one will just simply say, okay, I'll drop that for you. Right? Create table. you can also do if not exists. Right? And if it already exists, then it won't create it. But that's not necessary if you dropped it if it exists already. So you can go ahead and put those in there if you want to, but this statement up here that it's going to drop it anyway, so no matter what on line 8, it's not going to exist if you run this entire script at once. Okay. Oops. All right. That's pretty good for now. Of course, you want to insert test data. So insert. Remind me how to insert something. Create, retrieve, update, destroy. The create is going to be insert. What's the rest of it? Into film. And I don't want to have to worry about the film ID, but I do want to worry about the title, maybe the runtime, and the EIDR. Values, Dune. We'll go single quote here. Dune. I have no idea what the runtime of Dune is. Probably, do they have it here? Alternate IDs. I don't see any runtime. Okay. We'll just estimate it, and I'll cut and paste this. Let's just say 120. It's the cut version. There we go. And when I insert that into film, there. Now if I select that out, select everything from film, then I get that record right there. So somebody give me another film. Nobody has any movies that they like? Titanic. All right, I have no idea what the runtime there is, but let's go ahead and say 150 minutes. Right? What if I don't change this EIDR? Let me go ahead and run this and see if it works. It does work. Let me go ahead and select everything from film. What's the problem here? I've got Dune and Titanic, but they both have the same unique surrogate key. Or it's not unique anymore, right? This is allowed to happen because I have this primary key over here that is different. So how do we prevent something like this? We can put what's called a constraint on that, and that's where we'll pick it up on Thursday. Okay? Any questions? Okay. See you on Thursday then.